So today we are going to discuss total stress, effective stress and co-pressure of the soil mass. So suppose this is our ground level and we want to calculate the total stress at the plane x. This plane is at the depth of, suppose it is h, okay, and the unit weight of the soil mass is, suppose it is a gamma. So if we want to calculate the total stress at the plane x, so what is the stress? Stress is nothing but the load upon area. So total stress will be nothing but load upon area. So the load that is coming on the plane x will be nothing but the weight of the soil mass above it. Right? So what is the weight? Let me write down. This is the weight upon the area. And the total stress we denote it by the symbol sigma. Okay. So what is the total load that is coming on the soil mass? At the plane x-axis, the weight of the soil mass above it, and the weight of the soil mass will be nothing but the unit weight of the soil mass into the volume, right? So what will be the volume? Volume will be nothing but the area into the height. Here the area is, what is the area? Generally we consider the soil mass as a semi-infinite. The term semi-infinite means the depth, this depth of the soil mass is finite, but the area that we consider is infinite. Okay. So let me, this is for the understanding purpose only. Suppose this is a cube and we want to calculate the volume of this cube. So this cube must have some dimension, length, width and height. So that the area will be, for this, the area will be this width and the length L. But in this case we have this length and width as an infinite. Okay. So here we can see the term area will be cancelled out and the total stress will be the unit weight of the soil mass into the height h. Okay. So this will be the total stress. This total stress we also call as a vertical stress. Okay. We call it as a vertical stress also. Here we have considered only the soil mass, weight of the soil mass. When we do it, we also call it as a geostatic stress. So what is a geostatic stress? When we consider the soil mass only, then we call the total stress as a geostatic stress. And this is also called as a vertical stress. Total stress is also called as a vertical stress. Okay. If you want to calculate the horizontal stress, that will be something else that we will learn in the another chapter. But here what we are calculating is the vertical stress. Okay. So here I have mentioned we have taken only here the soil mass. Then we will call it as a geostatic stress. If there is some external load, okay, and then we will calculate the total stress total stress at the x-axis plane, then that will be called as a total stress only. That will be not as a geometric stress, that will be the total stress. Okay, so let me take some example. Suppose there is some surcharge. Okay, it is a surcharge which is kilonewton per meter square. Okay, means it is acting over the infinitely large area, right? So for this, surcharge over the infinitely large area, the total stress will become the geostatic stress that we have calculated. Okay, the height is h plus the surcharge, that is a q. Okay, so this will be the total stress. This is the geostatic stress, this one is the surcharge, right? Now, suppose the soil is fully saturated. For fully saturated soil, this gamma will become gamma saturated, right? So, what will the total stress? Gamma saturated into the height. If the soil is dry, that unit will become gamma D. So the total stress will become gamma D into the H, height H. Okay. So coming to this surcharge, here we have taken the surcharge over the infinitely large area. Okay, suppose if this surcharge is over the finite area, suppose there is a formation. Okay, and there is a load Q on the foundation. Then we can see that here the area is finite. The area of the foundation is finite. In this case, we generally take the base pressure जो यहाँ पर प्रेशर होता है वो जनरली इस तरीके से यहाँ पर डिस्ट्रीब्यूट होता है. ओके, सो if we want to see just below the foundation, the pressure will be what? The load upon the area of the foundation. But we want to calculate the total stress at this level. Then we will divide the load, this load, by the area of this plane. Okay. So that we will see in the when we will learn the foundation chapter. Okay. I am not going into this, but here you have to remember the surcharge when it is infinitely large area. then we can add directly into the total stress. Okay. Now come to the another topic, that is a coefficient. So now suppose the ground water table is at the ground level. Water table is at the ground level. And we want to calculate the flow pressure at the plane x-axis, that is below the height h. Okay. So if there is a water table, then there will be a hydrostatic stress. And hydrostatic stress, we know that is equal in the all the direction. So now suppose there is a particle here at height h. So at this particle, this pole pressure will be same in the all the direction, and the value of that pressure will be also the same, right? So as we have calculated total stress, that is total load upon the area, same here we will calculate the weight of the water and we will divide it by the area to calculate the pole pressure. So pole pressure we generally denote it by the symbol U, that is the weight of the water divided by area occupied by the water. Right? So here, if the unit weight of the water is gamma W, so what will be the weight? Gamma W into the height into the area. Area we will here take it as a AW, area occupied by the water. So from here we will get the pole pressure as the gamma W into the H. Here AW is the area occupied by the water. Okay. To understand this AW, take it as a simple case. Generally we assume the soil particle as a spherical. So suppose this is the one layer of the soil mass, and just below it there is another layer of the soil mass. So we can see here that one soil mass will be in a contact with the another soil mass, and that point of contact will be very small, right? So we can divide the total area into the two terms, that is area occupied by the water plus contact area of the soil. Okay. So here we can see this contact area, contact point is the very small. Okay, that is a point. So can we say that the area occupied by the water will be greater than the area of the contact? Right? So can we assume that the area occupied by the water is approximately equal to the total area? So here we can also take the total area instead of area occupied by the water, because area occupied by the water is nearly equal to the total area, total cross section area of the soil mass, right? So this was the pore pressure. This pore pressure was due to the water inside the soil, right? Now, if there is a air in the pores, so generally the weight of the air we take it as a zero, right? So pore pressure due to the air, okay, will be the zero, because the weight of the air we generally take it as a zero. But suppose this is the soil mass, okay, and there is a water inside the soil mass, and the air is entered in between the water. If this is the case, then the pressure exerted by the air, we cannot take it as a zero, and it will exert some pressure. So generally the pore pressure we will take it as a pore pressure due to the water plus pore pressure due to the air. So suppose UA is the pore pressure due to the air, and UW is the pore pressure due to the water. So the total pore pressure will be the total pore pressure will be UA 1 minus x plus x into UW, where x is the area occupied by the water. Okay. So if the area occupied by the water is x, then it will be x times UW plus the remaining portion will be 1 minus x, that will be multiplied by the pore pressure due to the air. So this is the formula for the when there is a air that is entered in between the water. Now let's come to the another topic, that is effective stress. So what is effective stress? Effective stress is nothing but the pressure that is transferred one layer of the soil mass to the another layer by means of contact. Means there is a contact in between the soils particle. So from that contact there is a grain to grain transfer of the pressure. We can say it as a grain to grain transfer of the pressure, right? So suppose the normal force that is transferred from one layer of the soil mass to the another layer through the grain to grain effect is sigma n. Okay, that is the normal force transferred through grain effect. Okay. Then the effective stress will be total stress, total normal force that is transferred divided by the total area. Here A is the total area. We also denote the effective stress as a this. Okay. So here we have taken the total area, not the contact area. As we have discussed earlier, the contact area is very less as compared to area occupied by the water. Right? So if we take the contact area, then this stress will be infinite. Okay. So and the dead stress we will call it as a contact stress. So what is a contact stress? When we will divide the sigma n by the area of contact, then the stress we will get is the contact stress. This contact stress is much larger than the effective stress that we have got here. So in generally the contact stress does not have any means. Okay, so we will not talk about that. We will only focus on the effective stress, that is the total normal force that is transferred by the grain to grain effect of the soil divided by the total area. Right? So this is the effective stress. This effective stress is very important because the soil strength, soil generally falls in the shear. Okay, so that shear strength of the soil mass generally comes by the this effective stress. Okay, if the effective stress is more, the soil will be dense. The shear strength of the soil mass will be the more. This strength of the soil mass we will discuss in the shear strength chapter. Okay, how this effective stress is important, you will see there. So now the effective stress is over. Now let us see some examples. So here we have seen the total stress, effective stress, and the pole pressure. Total stress is total load divided by the area. Pole pressure is the total load that is due to the water divided by the total area or area occupied by the water. You can take both. The effective stress is normal stress that is transferred by grain to grain contact divided by the total area. So can we say that the total stress is nothing but the effective stress plus pole pressure? Right? We can say that the total stress is nothing but the effective stress plus pole pressure. So for the fully saturated soil, so from here we can get the total minus 1. So in generally we can calculate the total stress, that is the load upon the area. We can also calculate the pole pressure, but we cannot calculate the effective stress directly because we don't know how much the normal force that is transferred by the soil by the grain to grain effect. Right? So here we cannot directly calculate the effective stress. So we will use this formula to calculate the effective stress. Let us take some example. Suppose the water table is here at height h1. We have to calculate the total stress, effective stress and pole pressure at the x-axis plane. This is the height h1, this is your height h2, this is the your unit weight gamma, gamma 1 or gamma, and this is your unit weight gamma saturated. Okay. So, and we will also draw the variation of this total stress, pole pressure and effective stress in the graph. So, let me make some, this is 0, 0, ground level, this is 1, 1, okay.